Hi, welcome to the video. My name is Pushpinder Gill, and this is going to be my email address, pushpinder08@gmail.com, and this is the Facebook page. You can go ahead and see all the updates here. That is facebook.com/perfectscores. So let's go ahead and get started. So today what we're doing is plugging in. So this is actually a technique that will help you to solve a lot of questions. Now there are two aspects to everything. There is a concept and there is a technique. Now students only take care of the concept part. So if you take care of only the concept part, you will not get that confidence to go ahead and do the question. You need the technique with you as well. So I'm actually planning to make up the series of techniques which will help you to get through the questions very easily. Right? Now first of all, what do you mean by plugging in? So why is this technique? Why am I planning to teach you this technique? Why am I taking this pain to put up this video over here? Now understand, numbers versus variables, that is arithmetic versus algebra. Now understand, algebra is something you would be weak at. You would every time be weak at. And arithmetic is something you will be strong at every single time, because this involves numbers and this involves variables. And since our childhood, we have been pretty equipped with numbers. You see the time at your watch, it's numbers. You see your bus number, it's numbers. But you have been very less. So this over here has been, you have been given very less stimulus to variables. So over here you're bound to make mistakes. So over here you're bound to make mistakes, and over here to get to the answer becomes a little difficult for you. Now if I tell you there is actually a way for you to convert all the algebra questions into simple arithmetic questions, and that technique is called plugging in. Now this technique will involve a series of at least 3 or 4 videos. So this is the first video on plugging in, where we'll be discussing how you plug in on simple questions, right? So let's go ahead and get this started. Now when to plug in? Now you have a question with you every single time, and you'll have your answer options, right? So if your answer options are variables, like x, 1 minus x or 1 minus x by 2, things like that, then is the opportunity to plug in. Then what you can do is you can actually pick a number for x, and then you can go about and do the question and see whether x is following the condition or not. So we're relying on the fact that whatever happens to x, the same thing will happen to whatever number that you choose. The same thing will happen to 3 or 4 or whatever number you choose. So it doesn't matter what number you plug in. What will matter is what operation you're doing on the number. So what I'm going to do is I'm going to use that technique on an easy question first, just the way it has been every single time in my videos. I will use that technique on a simple question, and then we're going to move on to advanced questions from there. Okay, so I'm going to keep writing the steps as well. So step 1, so over here I'm going to write my steps, right? So step 1 is your opportunity, that you should recognize that you can plug in, right? So your opportunity over here is your answer options have variables. So if your answer options have variables, just like in this question, you can very well plug in numbers and do the question easily, right? Now let's see this question. Now the question says that suppose you begin reading a chapter on page J and end it on page M, and all the pages are numbered and read consecutively. How many pages does the chapter has? Now step 2 would be to put a number for the variable. Now the variable over here is J and the other variable is M. So let's suppose I start the chapter on page number 2 and I end the chapter on page number 4. Now you keep these numbers as small as possible and as easily calculative as possible, right? Because this is the thing that you want to do in your question. You want to keep the calculation as simple as possible, and you want to keep your numbers to be pretty decent and pretty cute so you can go ahead and get to the answer. So now what you have to do is step 3. Once you've plugged in numbers, you have to work the problem, right? See what is the question asking you. Now if you've worked the problem, I say I'd start the chapter on page 2 and end the chapter on page 4. Now the question is asking me how many pages does the chapter has. That is your step 4, is to find out what the question is asking you. Now the question is asking me how many pages does the chapter has. So I have the chapter has page number 2, it has page number 3, and it has page number 4. So it has a total of 3 pages, and this is what my target is, or this is what the question is asking me to find. So the question is asking me to find how many pages does the chapter has. So it has 3 pages. Now your last step would be to eliminate all the wrong options. Now why am I eliminating all the wrong options rather than finding the right answer is because I'm actually relying on the fact I'm relying on by putting in numbers in place of J and M, and if this option does not satisfy this condition, that means that option is not right. So make sure you eliminate the wrong options, and in the end you'll be left with one option definitely. So over here, by putting J equal to 2 and putting M equal to 4, I should be getting my answer as 3. So is this 3? No, it is not 3. Is this 3? No, it is not 3. Is this 3? That is 4 minus 2 plus 2. Is this 3? No, it is not 3. Is this 3? Yes, it is 3. Now once it is 3, I should hold on. What if there is another option which is also giving me 3? Then I would have to go back and change the numbers and eliminate within those 2 options, right? So is this giving me 3? No, it is not giving me 3. That means my answer is option D, right? Now what is this approach? Now I'm just going to take a quick recap here, explaining you all the steps once again. Now whenever your answer options have variables, what are you going to do is if you plan to plug in, this is your opportunity to plug in. Then what you do is you pick up numbers for all the variables. Make sure the numbers are small and make sure the calculation is easy when you pick up those numbers, and then you work the problem and find what the question is asking you. The question is asking you how many pages does the chapter has. So you find that there were 3 pages in the chapter. So that means one of these options should be giving me answer as 3 and others should not be giving me 3. So what do I do is by putting J equal to 2 and by putting M equal to 4, I should be getting my answer 3. So what did I do is I eliminated all the options and I was left with one of the options. Now what are the features, or what can you expect from this technique? One thing that you can expect, you can expect is that it is safe. It's the safest technique that you'll have because you are actually relying on the fact, and B, it's quick, right? So it's definitely quicker than using algebra. In some questions you will be using algebra because those questions would be easier to use algebra, but when you plan to use plugin, it becomes really quick and it becomes really fast to use plugin, right? So make sure that if you plan to use plugging in, you definitely use it, and the answer options will have variables within them. So let's try to see the process. Now the process here is, step 1 is if the answer options have variables, you have the opportunity to plug in. Now plug in for the single variable, or if there are multiple variables, then you can plug in for that. Work the question, find what is the question asking you, and eliminate all the wrong options, right? So eliminate all the wrong options. Let me tell you something about the numbers that you have to plug in. Now what I want is, when you put in the numbers, it has to be small and the calculation has to be good enough. One advice that I would like to give you is stay away from 0 and 1, right? So you have to stay away from 0 and 1 is because these are the numbers which eliminate all the calculation abilities. What if the answer options are 2a, 3a, 4a, 5a? If you put a equal to 0, all the options will become same. So I would actually want you to stay away from 0 and 1. These are the numbers which do not work with this technique. Right? Now this technique is a little unorthodox. You will not be taught this in high school, but believe me, when it comes to standardized testing, when it comes to GMAT, or when it comes to CAT, or when it comes to SAT or GRE, this technique is a lifesaver. Believe me, I've gone through the process. All right, so let's show you how this technique works. All right, so don't do this question. I'm going to do this question with you, right? It's a medium level question, not too hard, not too easy. Now, understand this. Step 1, answer options have variables. Bingo, I should plug in. Now, it says that x is an even integer. Then which of the following is the sum of next two even integers greater than 4x plus 1? So let's say x is equal to 2, because it's saying that x is an even integer, so I put x equals to 2. Now it says that which of the following is the sum of next two even integers greater than 4x plus 1. So what is 4x plus 1? That is 4 into 2 plus 1, which is 9. So the question is asking sum of next two even integers greater than 9. So what are next two even integers greater than 9? 10 and 12. And their sum is 22. Now this is what the question is asking me to find. So by putting x equal to 2, I should be getting my answer as 22. So this over here is not 22. This over here is not 22. This over here is 22. Hold on, this is not 22, this is not 22. That means my answer is option C. Right? So suppose you've understood the question. I've placed this question so that you understand the process. Once again, my step 1 was to find the opportunity to plug in. Right? So if I can plug in this question, bingo, I'll do that. Then I plugged in numbers for the variables. So I gave away numbers to the variables. Step 3 was I worked the problem. Right? So I worked the problem and I made sure that I find what the question is asking me. So I found the target. And step 5 was eliminate all the wrong options and get to the right answer. Right? Why am I emphasizing on this process is it's because it is very important that you do it step by step. Right? So it's very important that you follow the process. If you don't follow the process, this technique can be a blunder for you rather than be a wonder. Right? So that is the case here. Let's see another question here. Okay. Alright, so let's see another question. Now this question over here says that David will jog from home at X miles per hour and then will walk back home by the same route at Y miles per hour. How many miles from home can David jog so that he spends a total of T hours jogging and walking? So you see there are so many variables involved in this question. It's better that we plug in here because answer options have variables as well. So what if, let's suppose I say the distance that the value of x is equal to 5. Alright, so he will jog at the rate of x miles per hour and will walk back home. So let's do one thing. Let's say the value of x is 10 and the value of y is 5. You have to be smart in putting in your numbers, guys, right? And let's suppose the distance is 20 miles, right? So let's suppose the distance is 20 miles. Now we have to find the value of t. Now what is the value of t is the hours spent jogging and walking. So to travel a distance of 20 miles at the speed of 10 miles per hour, it will take him this many hours. And to travel the speed of 20 miles at 5 miles per hour, it will take him this many hours. So that would be 2 plus 4, that is equal to 6. Right? So now the question is asking how many miles from home David can jog. So he jogged a total of 20 miles. So actually the question is asking me that these answer options should be 20 by putting x equal to 10, by putting y equal to 5, and by putting t equal to 6. By putting these values, my answer should come out to be 20, which is my target. Very important to circle it and write it down because this actually helps you to process you from here to the options, right? So I'm just gonna do it once again. I assume the distance to be 20 miles, and I said x equals to 10 and y equals to 5, and t hours are spent jogging and walking. So t hours is 20 by 10 plus 20 by 5, that is 6 hours. So the question is asking me how many miles from home David jog. So he jogs 20 miles, right? He goes 20 miles and comes back 20 miles. So he jogs 20 miles only. So my answer should be 20 by putting x equal to 10, y equal to 5 and t equal to 6. Let's see whether which option gives us that answer. So the first would be 10 into 6 divided by y. So that would give me actually 12. This is not what I'm looking for. This one would be x plus t, that is 16, divided by x into y, which is 50. This is again not giving me the answer. The third is x into y into t divided by x plus y. So that would actually give me 20, which is what I'm looking for. Hold on, we have to eliminate all the wrong options. So this is 10 plus 5 plus t divided by x into y, which is 50. This is again way too smaller number. This actually becomes 5 plus 6 divided by x minus t by y. This actually becomes not an integer, so that means my answer is option C. Right. So you see the cleanliness, the way I have done this question. You would see you have 75 minutes for 37 questions in GMAT. For CAT you have ample amount of time. So you can do this question easily within 2 minutes. So 2 minutes is your target in which you have to do a question, and I think it's pretty doable over here, right? So suppose you've understood this. What I've done is I've followed the same process, and in the end I have eliminated from the options, right? So let's move to the next one. Now this question says that again answer options are variables, so I can plug in. Now the question says that a case contains C boxes, right? So a case, so let's suppose there is this case here, right, and it contains C boxes. So it contains C boxes, and each box contain B bags, and each bag has 100 pins. So let's suppose the value of C is 2. Let's suppose each case contains 2 boxes. This is one box and this is the second box, and each box contain B bags. So let's suppose the value of B is 3. So there is one bag here, second bag here, and third bag here, one bag here, and second bag here, and third bag here. Now it says each bag has 100 pins. So each bag will have 100 pins. So that means each case will have 100, 100, 100 and 100, 100, 100. That is 100 into 6. Each case will have 600 pins. So since each case will have 600 pins, the question is asking me how many pins are there in 12 cases. So if one case has 600 pins, 2 cases will have 1200 pins. So by putting C equal to 2 and B equal to 3, I should be getting my answer to be 1200. Let's see whether we can find that. This is 100 into BC, that is 600. So this is not the answer. This is 100 into B by C, which is way smaller, which is like 150, not the answer. This is 200 into 6, which is equal to 1200, which is what I'm looking for. Hold on, we have to eliminate all the options. This is 200 into B by C, which is again 100, not the 300, not the answer. This is 200 by BC, which is way smaller, again not the answer. That means my answer is option C. Right. So you see again the cleanliness by which we do the question, and I'd say this approach is the safest approach that you'll ever have for solving aptitude problems. And you would see the applications of this approach when I move to the advanced case in plugging in 2 and plugging in 3 video. Right. So suppose you've understood this question. Let's move forward. Okay. So now I'm going to move to a little advanced stuff, right? So some tough questions which would actually completely give you a lot of challenges when you apply algebra to those questions. Now this question says that, I'm going to read the question out for you. It says last Saturday a certain store sold copies of magazine A for $1, so and copies of magazine B for $1.25. So there was magazine A involved and there was magazine B involved, and each magazine was for $1 here, and each magazine was for $1.25 here. And the store sold no other magazines that day. Now the question says that if R% of the revenue from magazines was from magazine A, and this is in terms of revenue, and the P% of the magazine that the store sold was again from magazine A. So this is numbers of magazines sold. Now the question is asking what is R in terms of P, right? Now let me say one thing, let me say A sold 10 magazines, there were 10 A magazines sold and there were 10 B magazines sold. Right? Let's make it that way. So there were 10 A magazines sold and there were 10 B magazines sold. Let's keep it simple. Let's say 100 and 100, right? Because I want the numbers to multiply equally here. So what percentage of what is the value of P here? What percentage of the number of magazines were sold by A? That is 50%, right? So the value of P is 50. If I say 100 magazines sold here and 100 magazines sold here. So if I say 100 magazines were sold and each magazine costs $1, so that means the revenue generated from magazine A was $100 and revenue generated from magazine B was $125. So what is the value of R? It's 100 divided by 100 plus 125. It's because the question says that R is the percent of the store's revenues from magazine sales from magazine A. So what percentage of the total sales were for magazine A? That is 100 by 100 plus 125, that is 225 into 100. Right? So if I cut this by 25, this comes down to be 25 and this comes down to be 4. Right? So value of R comes down to be 400 by 9. So by putting P equal to 50, I should be getting 400 by 9. Right? So that is the value of R. So if I put P equal to 50, my answer should be 400 by 9. Let's see whether we can get that or not. So I'm going to write A, B, C, D, E here. Now A over here is 100 into 50 divided by 125 minus 50. Right? So that is actually equal to 75. So 25 times 3, 25 times 2, that actually comes down to be 200 by 3, which is not what I'm looking for, not the answer. This becomes 150 into P. So 150 into P is 50 divided by 250 minus P. So that is divided by 200. So this completely goes on 4 and this comes down to be 150 by 4, which is not my answer. Similarly, if I try to use it for C, so I'm a little short of space here, that is 300 into P, that is 300 into 50 divided by 375 minus P. So 375 minus P would actually become 325, right? So even if I try to calculate, so this actually is not even a multiple of 9, so that means this is already eliminated. I need the 9 at the bottom, and this becomes 400 into P, that is 400 into 50 divided by 500 minus P, that is 450. So that actually becomes 400 by 9. Straight away I have my answer. E is definitely not my answer because that is 625 minus 50, not even a multiple of 9. So that means my answer is option D. Right? So you see, when you use plugging in, what happens is the process of doing the question becomes a little longer, but getting to the answer becomes a little easier and a little safer, right? So that's what happens when you use plugging in. It becomes so simple. You just see a question and you put in numbers and bingo, your question is done, right? So suppose you've understood, I'm going to do the question. I'm just going to redo the question with you. It says magazine A cost $1 and magazine B cost $1.25, and I say let's suppose 100 magazines of A were sold and 100 magazines of B were sold. So it generated $100 here and it generated $125 here. The value of P was 50 because 50% of the number of papers sold were from newspaper A, and the value of R was 400 by 9 because that was the percentage of revenue generated by R. So by putting P equal to 50 and by putting R equal to 400 by 9, I should by putting P equal to 50, my answer should be 400 by 9, and only D option is giving that. That is my answer, right? So the only thing is you have to be a little smart about picking up numbers. That's the key here. Okay. All right, so let's see this question, and so I'll actually do one thing. I'll actually challenge you to do this question using algebra. The day I saw this question, I just used plugging in. It was just inside my head that this is what I have to use here, right? So let's see this question. It says David painted a red wooden cube. Okay, and he painted a red wooden cube. Sorry, this should be different color here. Let's suppose he painted it white color. Okay, right? Should be white. Okay, let's see. David made a painted red wooden cube and then cut into x cube smaller identical pieces, right? And so how many of the cubes will have at least one side painted white? So what did he do in this question is, he had a painted cube already painted, right? So the color was red and he painted it white. Okay, so he painted it white. Now he says that he painted into x cubes smaller and identical pieces where x is greater than 2. Now since the value of x is greater than 2, the minimum value of x that I can think of is 3, right? So what did he do is, he cut it into 3 cube smaller pieces. So he cut it into 27 smaller pieces, right? So let's suppose he painted it white and then cut this into 27 smaller pieces. So this is the way he will cut this into 27 smaller pieces. Now if you remove all the cubes will have at least one side as painted white. The only cube which will not have one side as painted white is the cube which is exactly in the middle. That cube will not have any of the sides as painted white. So that means out of 27 cubes, one cube will not have any side painted white. So how many cubes will have at least one side painted white? So how many cubes will have at least one side painted white? That would be 26 cubes. So 26 cubes will have at least one side painted white, right? So by putting x equal to 3, my answer should be 26. Just gonna do this process once again. Let's suppose the value of x is 3 and he cut this cube into 27 pieces, right? Before cutting, he painted all the sides as white, and how many sides will not have any side as painted white? That would be the only cube in the middle. Rest every cube will have at least one side painted, right, which is 27 cubes. So by putting x equal to 3, my answer should be 26. So let's see which one gives us 26. So A, B, C, D, E. This is 9, no. So I'm putting x equal to 3, huh? So this is 15, no. This is 6 into 3, that is 54, no. So this is 6 into 9 plus 10 into x, that is 30 plus 20, which is way bigger than 26, no. I'm left with this, but still let's check it. So it's 2 into 3 into x square minus 6 into x plus 4. So if I put this here, this becomes 27 minus 18 plus 4. So this becomes 2 into, what is 27 minus 18 is 31 minus 18. So that actually becomes 2 into 13. So that actually becomes 26, which is what exactly I'm looking for. Hence my answer is option E. Alright. So did you understand? So I just want you to understand. I just want you to realize that what power this technique has. This technique has such a wonderful power that it can do wonders for you. Really big wonders. You can see a difficult question. See, I can become Michael Jackson and show you questions, show you way of doing questions which is very difficult, and you'll say, wow, Pushpinder, you just blew my mind. But what I want is, I want to make your life easy, right? So this technique might be a little hard to digest because it makes your life easy, and something which makes math easy is something which our brains doesn't catch. Yeah, so let's see this question. Now this question says that mean of n items is x. Alright, fine. So let's suppose the n items, let's say these n items are 3 items. Okay, so 1, 2 and 3. Let's suppose these are the numbers. Their mean is x. So what is the mean of 1, 2, 3? The mean is 2. So this is what it is. Now the question says the first item is increased by 1, second is increased by 2 and so on. So these were the items. First is increased by 1, second is increased by 2 and third is increased by 3. So the items become 2, 4 and 6. Now the new average becomes 4. So by putting x equal to 2 and by putting n equal to 3, I should be getting my answer as 4. Okay, so by putting x equal to 2 and by putting n equal to 3, my answer should be 4. So x equal to 2 plus n plus 1, 4 by 2. So this is actually giving me 4. Hold on. This becomes x, which is 2 plus n by 2. This is not 4, so this goes away. So this is x, that is 2 plus n. This is 5, goes away. This is even greater than x plus n, and this is even greater. So my answer is option A. See the simplicity with which we can do a question, right? So you don't need that complex sigma n or sigma n plus square or sigma n cube. You don't need all that. All you need is basic understanding of how to do a question, and you just cheat your way through, right? So that's what I want you to learn. Alright, so I suppose you've understood. It says the mean of n items is x. I say let's suppose there are 3 items, 1, 2, 3, and their mean is 2, and first increased by 1, second increased by 2, third increased by 3. They became 2, 4, 6, and in the end I just plugged in and I got the answer. Okay, alright, let's see this question. Now this question says that a coin is flipped a number of times, landed on heads y more times than twice the number of times it landed on tails. If h is the number of times, so let me get a red pen, that would actually help me here. Okay, now if h is the number of times the coins landed on heads, how many times the coin flipped in terms of h and y. So let's see whether we can do this question. Now this question says that the coin was flipped, landed on heads y more times than twice the number of times it landed than on tails. So let's suppose it landed on tails 2 times, right? So let's say it says the coin flipped the number of times, landed on heads y more times than twice the number of times it landed on tails. Let's say the value of y is 3, right? So the value of h would be 3 plus 4, that is 7. Now the question is asking how many times the coin was flipped. So the coin was flipped, the number of times heads came and the number of times tails came. So the coin was flipped 9 times. So by putting t equal to 2 and y equal to 3, I should be getting my answer as 9. So let's see whether we are getting that. So by putting the value of h is also 7, right? So by putting h equal to 7 and y equal to 3, my answer should be 9. So that is 7 plus y, that is 3. So this is not 9, right? So that is y, 3 plus 7 by 2, which is again not 9. This is h minus y by 2. This is again not 9. This is 3h, which is 21, minus 3 divided by 2, which is actually 18 by 2, which is 9, giving us the answer. Hold on, okay, this is something which is same, not the option. That means my answer is option D, right? See, this is a typo here, both options are same. Right? So you see, again I'm emphasizing the simplicity with which we are doing questions. That's what I want to emphasize. All I do is I just put in numbers there. That's what I do. Even a 12th grade student can answer this question, right? So it's not a difficult question at all. So that's what I'd say. It's keep things simple, and it would be there. So some don'ts, some things that you don't have to do, it's stay away from 0 and 1. I've emphasized on that, and eliminate all the wrong options. So this 2 things, I would say from experience I've learned that you have to stay away from 0 and 1, eliminate all the wrong options. Sometimes you get more than one option giving you the same answer. So you don't want that. You don't want to be going all the way through and still ending up with the wrong answer, right? So make sure out of all the options you are able to eliminate all of them and able to get to the right answer. right? So these are some don'ts. So this again, I end up everything with a CAT question. So for my viewers who live overseas, this is one of the toughest exam in our nation. Supposed to be toughest, but it's not that tough at all, but it's way more tough than the exams like GMAT or SAT. So let's see, it says that which one of the following conditions must PQR satisfy so that the following system of linear equations has at least one solutions such that this blah 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 blah. So as soon as I see this, one thing that should turn to my mind is that I should plug in. Let me say that the value of, so I just have to put in the value of x, y and z, right? So let's say z is 2, y is 3 and x is 4, right? So what is p now? So p is x, which is 4, plus 2y, which is 6, plus minus 3z, minus 3 into z, that is 6. So the value of p is 4. What is the value of q according to the question? 2 into x, which is 8, plus 6 into y, which is 18, minus 11 into z, which is 22, right? So the value of q comes down to be, so this actually becomes this becomes -4, so 8 minus 4, it also becomes 4. Right? Now let's see what's the value of z coming out to be. So the value of z is equal to, it's not z, it's r, right? So the value of r is equal to x, which is 4, minus 2y, which is 6, plus 7z, which is 14, right? So this is -2 and this comes down to be 12. So the value of r is 12. So from the options, which of the options satisfy? That's what we have to check. First option is 5 into p. So you can very well see only 5p and 2q and r are being used. So I could just write 5p is 20, 2q is 8 and r is 12, right? So this is 5p minus 2q minus r is equal to 0. Is it true? Yes, it is. Hold on to it. This is 5p, which is 20, plus 8 plus 12, not equal to 0. That I'm just satisfying the equation. 20 plus 8 minus 12, not equal to 0. Gone, right? Similarly, 20 plus 8, okay, so that was 20 plus 8 minus 12. So this is 20 minus 8 plus 12, again not equal to 0. Gone. There is no E option. That means my answer is option A. Difficult at all? Is that difficult at all, guys? It's not at all difficult. I think you must be saying now, right, wow, what just happened? So that's what I want you to do. That's what I want you to do. In a very simple and sophisticated way, you just kill this question off, right? So this is the kind of approach this is, right? So I suppose you understand. I've done nothing brilliant. I've done nothing which is too difficult for you to understand. I just put up some values for x, y and z, right? And just found the values for p, q and r and just went on with the options, right? So we're just relying on the fact whatever happens to p, q, r, the same thing will happen for x, y and z, and same thing will happen for 1, 2, 3, right? So that is what we're relying on. So suppose you've understood this now. So I'm actually planning to put up the series of plugging in. So this was plugging in 1, wherein I have explained about the simple plugging in, where answer options are variables, right? Now I would be coming with one big bomb second video where you would really thank me for that. It's such a great advanced version of plugging in. So we'll be coming with that and some more videos on plugging in so that you understand the concept and understand, guys. I'm not hiding anything from you. So all the technique that you've learned, they is something that you pay for, and you don't have to assume that there is something that I'm hiding. Everything is yours, right? So that's what I believe in. So make sure you do send me your valuable feedback and you do like this Facebook page, right? Understand your appreciation and your sharing is what is the currency on which I'm living, right? So so thank you very much, and I'll see you in the next video. Bye bye.